Hello dear friends and welcome to another electronics tutorial. Today we're going to build a Night Rider light. It looks like this, so it goes from one side to the other and then back again. We are going to use TinkerCad for this, and for this you can go to tinkercad.com and then create an account, and the software is free. So let's get started. First, we have to create a new circuit, and TinkerCAD will create this canvas for us, where here we will we will place all the components. First of all, we are going to select from components all components, so we can see also the Arduino microcontroller. So we will get a full Arduino board here. And also for this tutorial, we are going to need a breadboard, just that we organize ourselves a bit better here. Okay, so the first thing we need to do is just light one LED to see how we program Arduino and how the code is working. So I'm going to take from the library one resistor just to limit the current for the LED. And then I am going to take a LED from here, and as we've discussed in the LED tutorial, the LED has to be supplied from the anode to the cathode to conduct to emit light. And for this, we're going to connect this LED light to to a pin on the controller. So I'm going to use pin 0 here, which is the digital 0 pin here. And then we will also need to connect the ground from the ground pin of the Arduino. So I'm going to connect the ground initially here, and then I'm going to pull a line from this side to the top. So in a breadboard, as we've discussed in previous tutorials, all these pins are connected one to another, and also all the pins on this line are connected one to another. Last thing we have to do is connect the cathode to the ground pin. So I'm going to do a small connection here, and the circuit is set. So what we first plan to do is to supply the LED through this resistor. Let's see how big this resistor is first. So this 1 kilo ohm, it's a bit big as a resistor. Let us put like 200 ohms here and see if the current is still too much. Maybe we can lower this also. These LEDs are 20 milliamp LEDs, so yeah. First step, in order to use the Arduino, we have to go here to the code, and here we have to select the text, uh, the text editor. So here it's already a small code. So let's just first discuss the small introduction code. So this is just a blinking LED. So the embedded software is designed to have the initial setup, where we define the pins and all the setup required for the application, and then an infinite loop, which is the void loop function here, which runs constantly. So initially we go through the void setup, and then everything happens in the loop here. Okay, great. So then let us set pin 0 as an output. So I'm going to set pin 0 as an output, and then first we're going to put it on. So pin 0 is going to be on, and then we have a delay of 1 second. So here, as it's written here, wait 1000 milliseconds, which is 1 second, and then the pin then goes low. So a pin being high means that it's supplied to the supply voltage of the Arduino, and in this case it's 5 volts. So the pin will be supplied at 5 volts, and if it's high and if it's low, it's going to be connected to ground, or the voltage reference 0 volts. Let's see how this works. So let us start the simulation, and we can see that the LED is turning on and off and on and off. For 1 second it's on, 1 second it's off. We can also change the timing here, so we can reduce the time that it is on. Let me stop the code a bit. So we can put here like 500 milliseconds with 500 milliseconds, and now it should blink faster. Yeah, it works quite nice. Okay, so the next step now is to create the Night Rider LEDs. So for this, I'm going to use the same structure here. Maybe move this a bit to the left here so that they're aligned. I'm going to delete this line here. I'm just going to take this here, and I'm going to copy this resistor multiple times so we can place multiple LEDs together. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then I'm going to copy the LED here and just put LEDs one after another so that, let me zoom in a bit, maybe this helps a bit. So I'm just placing the LEDs one after another, and all the anodes are connected to the resistors. And what we have to do is, because here it's ground, we have to connect the cathode to the ground. So we are going to take each of the cathodes and connect them to ground through a wire. Okay, just a few more. Great. So now we have just connected only the first pin here. Let us continue and connect the second pin. So I'm going to connect this to the D1 pin in the controller, or the digital 1 pin. This is digital 0. So here are from digital 0 to digital 13 pin. And here are analog 0, 1, 2, 3, 4, 5 pins. So the main difference is that for analog pins, here you can read analog values. So you can read 0.7 volts. You have an analog to digital converter inside the controller. And for the digital pins, you can only read if the pin is high or low. If you have voltage or you don't have voltage. Okay, so let us continue to connect the pins. So we have connected pin 2 and pin 3, digital pin 3. Let me move this also here, tailor this a bit. Okay, pin LED 4 to pin 4, LED 5 to pin 5, LED 6 to pin 6, LED 7 to pin 7, LED pin 8 to LED 8. Let me structure this a bit. Okay, much better. You also have these guiding lines here when you're dragging from one side to another. And then pin 9 over here. Okay, and I believe we can put another LED here, just that we have a longer line of LEDs. Let me place another LED here. Okay, and then just connect it here. Okay, it's connected, and then place another LED. Okay, and now it is connected. Great, great. Oh, here I think these are wrong. So these should go to the pins here. Okay, because all the pins here are connected. So if I would have connected this, I would have connected all the pins here to ground, and we don't want to do that. If we supply the controller, we will be dragging all the current from the controller pin to ground, and we run the risk of destroying the pin. Okay, and here is the last pin. Great. Now all we have to do is go to the coding side. So here, usually, let me split this a bit so that is clear. So here we have the initial setup where we define exactly the inputs, outputs of the pins. If we're going to do any input, if we have, for example, some pins that are going to be an input, we define them here. Then here, this is the infinite loop where we constantly run code. So first, let's set up these pins as inputs. So I'm going to create a vector called pin, and let us define this vector from 0, pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, pin 8, pin 9, and pin 10. Great. Then we will also need a helper function, helper parameter. So on this side, let me delete this. I'll write here variables, and here we define these are the global variables that we're going to use in all our code. So I'm also going to create an int for I, which is going to help us initialize all these pins quite fast. So in the initial state, I will delete this, or maybe not. Maybe I'm going to use this code, and then I will write a for loop. So for I equals 0 to I less than 11, because we were having here 11 including 0, we're going to define I plus plus. So this means we are just going to increase this I value. Okay, and we open parenthesis here, and in this what we want to define is put every pin as an output, so that we don't write pin 0 output, pin 1 output, pin 2 output, just to simplify a bit our code here. So pin of I will be output, and this will set all the pins to be an output. This is great. So now we have set the pins to be outputs. The next step for us is to go through the infinite loop. So first, here we are increasing I, so we have to reset I to 0. And we have to first traverse the LEDs. So how we're going to traverse these LEDs, we're going to turn pin 1 high, then turn it off, then pin 2 high, turn it off, pin 3 high, turn it off, pin 4 high, turn it off. And between going high and being turned off, we're going to place a delay, which will give us the timing, how fast the light goes from one side to the other. So let's create a while loop. So while I is smaller than 10, okay, while it is smaller than 10, we are going to write to push these pins high. So digital write, well, we have it here, so let me copy this. So digital write pin of I, and we write it high. Great. Then we have a delay, because if we just write it high and then low, there will be no time between this, and it will go very, very fast from high to low. So now we add a delay. 500, it's quite a big delay. Let me put 100 milliseconds. We will see it quite good in the simulator. And then we are going to turn it off. So we're just turning it on for 100 milliseconds and then putting pin I low. Great. Okay, let us see how this, and of course what we need, because this is not uh, this is going to run in loops. We need to increase I, because I, we set it here to 0, and now we need to increase it. So then we're going to do I plus plus. This increases I by 1. Okay, so just to recap, and I'm going to copy this comment here. So on this line, we reset I after we have initialized every pin to output. Then we go into a while loop where we go through all the pins, turn each pin on, wait 100 milliseconds, and then turn each pin off. And then increase I, which is our counter here. Okay, great. Let's see how this works. So this, what we are aiming now is to see that the LEDs are turning, all LEDs are turning from left to right. Okay, okay. I expected before error, expected a comma before, expected a comma before. Okay, I believe I forgot here a comma. Let us start again, and it is working. It is working, and it's unfortunately it's not reaching the last LED. Okay, because I put here 10 and should have been 11. Let us see how this works with 11. And yep, beautiful. So they're working one side. Now what we have to do is do the same thing for when this reaches 11, we have to go back to 0. So let me stop the simulation, and then I'm going to do another while loop, and we can copy this whole while loop here, and then here I is it's 10 because at 11 it breaks. So here we are going to put while I is greater than 0, and what we're going to do is decrease I. So do the opposite. We're going to go from 11 to 0. And now the first while goes from 0 to 11, and then from 11 to 0. So let's see how this works. Okay, great. It seems to be working great. Okay, so what we have done is we have managed to do a Night Rider light with a fixed delay of 100 milliseconds. This is great, but what we can how we can improve this project even more is to add frequency input for this light, so we can make it go faster from one side to another, or we can make it go slower. So to do this frequency input, we are going to use a, let me open the components. We're going to use a potentiometer. We have discussed potentiometers in the resistor training. If you need more information regarding this component, you can find it there. Okay, so this is quite big. 200 kilo is like really big. 10 kilo is more than enough. So first of all, we need a 5-volt line here, so I can put this to the potentiometer. So I'm going to take the supply from here and connect it to this line here. And we can remember this is the ground line and this is the supply line. So now I'm going to supply one pin of the potentiometer to the supply and the other pin to ground. Great. And the value for the wiper will vary. I'm going to take this value here and then input it into the analog pin for the microcontroller. So I just put it here. Great. So this means that now we can read values from the potentiometer. And let us do even more. I'm going to take a multimeter and place it here. I'm going to put the negative to this line, and then I'm going to put the positive so we can see even the values for this. We can see exactly if this is 0.5 volts, is it 3 volts, is it whatever. Great. So our code isn't changed. The light is still working great. Let us then look at the code. So first of all, we need a value, variable for the input from the parameter. So let us create an int value. We can call it POT from potentiometer. We can initialize it with 0, and now we've created this value. Okay. First, we have to, in the setup, what we have to tell the controller is, hey controller, we are expecting an analog input on pin A0. The way we do this is not with it is with pin mode as we did for the other functions, but here I'm just going to write pin mode. So we're going to set pin A0 to be a input with capital letters. Okay, so now we have set up the input. Great. Now we're going into the loops, and what we want to add is we want to change this delay here to value that is the value from the potentiometer here. So what we can do is we can add here at the beginning, we can add a value. So potentiometer will receive the value and do a analog read. We call the analog read function. What do we want to read? We want to read A0 pin, and then just read this pin, and according to this pin we will create this delay. So here we can write the potentiometer value. One thing that I have to mention, so this is a 10-bit analog to digital pin. So what would the controller do is take this value from the potentiometer and then divide it into or find the equivalent in 0 to 1024. So this is quite high of a value. So 1024, if we have the maximum, so for example, here the potentiometer is at 5 volts. If we leave it at 5 volts, this means that the LEDs will move very, very slowly because the value input from the potentiometer is 1024, and he takes this 1024 and um, it creates a delay of 1024 milliseconds, which is a very high delay. It's 1 second and 24 milliseconds, and it's a bit high. What we want to do is to reduce this value a bit because it's quite high. And then I'm going to, just for fun, I'm going to divide this value into two. So this means that we're not going to get 1020 23. We're going to get 511 here. So this would be the maximum value that we can read. Okay, and we're going to do the same for the return um, for the return value. So I'm going to take this value here. The potentiometer is going to read the value from a 0 divided by 2, and it's going to create a delay based on this value. Okay, great. Hopefully I did not forget any punctuation here. And let's start. So you can see here it's 5 volts and everything is moving quite slow. I think here I overstepped this. Yeah, just 1 second. This is 10 and here it is 10. Let me run it again. And it's going and it's going and it's going back. And I think this resistor is higher. Yeah, no, 200 ohms. It's a bit less bright than the other resistors, the other LEDs here. This is red and this is red, and the 200 ohms, the one next to it is 200 ohms. That's weird. Okay, so let us start the simulation and let us increase the time here. Now you can see you can use the potentiometer just to increase the time this is switching on and off. Quite fast and quite efficient. And then we're going back to the slow, turn on and turn off, and then back. Here I think it's a coding error from my side. So this is more than, more or equal. More or equal to 0. Let me start this again. Let's see if this fixes it. No. Okay. Yeah, it starts from if this is higher than 0 and higher than 10. Okay. And then you can increase here the value for this. You can make it go as fast as you want. Here you are just moving it really fast. You can also change in the software the color, so we can put like blue LEDs everywhere, for example. And yeah, it's quite nice that you have a lot of flexibility in the software that you can do. Oh, that you can do a lot of quick prototyping. If you want to add another LED string to this, you can add it, and it's quite efficient. So let's start this again. Okay, you can see it's moving quite fast. Okay, okay, so you can see here the meter with the frequency variation. You can change this. This is a great project, as I said, to do with a daughter or a son if you want to introduce them to electronics. It has the simple Arduino code. All the functions are defined here. You don't need a lot of technical background to build the software for the application. And yeah, it's quite flexible. So wish everybody a great day. Thank you for your time, and let's keep in touch for future videos. Please comment if you like our videos, and we will try to create great content for you to enjoy. Wish everybody a great day. Bye bye.